Welcome everyone to my LeetCode Biweekly Contest 144 livestream. If you're here for solutions, jump ahead to 90 minutes in or use the timestamps in the video description. In a few minutes, we'll be doing the contest live and answering questions, giving hints in the chat. So come join us every weekend for the contest. No code will ever be shared while the contest is running, but immediately afterwards, we will go through the answers for all 4 questions. So make sure you stick around. If you enjoy LeetCode content, do check out the rest of my channel. I have videos on different problems as well as the hardest question 4s of previous contests. And as usual, like and subscribe to stay up to date on new videos. Alright, the contest is about to start. There's about 3 or 4 minutes left. Let me just check who's around right now. Hi, good to see you again. It feels good to participate again. Yeah, it does. It does. Yeah, I feel like your skills get rusty if you miss a few weeks. I think in the middle of this year I missed almost a month of contests, and yeah, it's so weird coming back to it afterwards. Well, I'm glad you're here, and I'm glad that you are not just participating, you're also joining us on this channel and working on contests together. So welcome. Alright, just a couple minutes before we start. 3 minutes and 42 seconds according to the chat log. 1 minute according to the chat log. Hopefully, oh, I forgot register. Oh, gotta register now. Yes. So once again, for folks who are new to the stream, I don't share my code on screen. I code on a different screen. So if you don't see anything happen on screen, it doesn't mean that I'm not doing anything. It means I'm actually working, and I don't want to share answers during the contest, so you don't get to see it. However, if you ask questions, I will answer. Let me see. There's something wrong with my my dark mode. Okay. I think this is better. It's kind of unfortunate. I don't like the bright mode, but in dark mode you actually don't see the words here because they are white. Yeah, I think I might fix that. All right, contest is begin. Good luck, everybody. Okay, let's see. Question 1. 3, 5, 5, 6. Oh, this hopefully is an easy contest, according to his points anyway. But who knows, right? This kind of stuff. Okay, question 1. Alice and Bob are playing a game where they take turns removing stones from a pile, with Alice going first. Alice starts by removing exactly 10 stones on her first turn. For each subsequent turn, each player removes 1 fewer stone than previous opponent. So 10, 9, 8, 7, 6, 5. Oh, 10, 9, 8, 7, 6, 5, 4. Return positive integer n. Return true if Alice wins the game, otherwise false. Okay, this should not be too difficult. Once again, if you need help, if you ask questions, I'm gonna ask you to try it out yourself a little bit first. If you do get stuck, let me know. I'll talk about it on the on stream, even though I probably will not give very obvious hints. Oh, why is this not showing? All right. All right. First one done. Second question, shift distance between two strings. Let me just check there are no questions out. I think the first question is not super difficult, so hopefully there are no questions. Second question, you're given two strings S and T of the same length and two integer arrays next cost and previous cost. In one operation, you pick any index I of S and perform either one of the following actions. Shift SI to the next letter in the alphabet. Okay. Two integer arrays, next cost and previous cost. Shift SI to a previous. If SI equals to A, you should replace previous cost is go backwards. Next cost is go forwards. Okay, so you basically can to turn S to T, you go forwards or you go backwards. Shift distance and minimum cost to transform S to T. Okay. So for this one, you probably want to calculate the forward distance and the backward distance and then compare which one is faster. Alright. And let me just make sure. Let me make sure I'm understanding this correctly. So AB, AB. We choose S0 and shift it 25 times to the previous character for a cost of 1. Oh, okay. And then the second one with cost of 0. Okay. So this is kind of tricky. The forward cost and the backward cost is not the same. The forward cost and backward cost is from this array, and it can be pretty wild. Okay, and some of them can be 0. I wonder if some of them can be negative. Can the cost be negative? Okay, the cost can always has to be positive. So you cannot shift something extra times and then get, like, if the cost is negative, you can shift it a whole bunch of times to get it to get like 3 points. Shift S0 25 times to the next cost of 1, and why is I012 to the previous character for the total cost of 1? Wait a second. This operation shift cost J, where J is the index of SI in the alphabet. Oh, okay. So next cost and previous costs are length 26. Okay, I gotta read this carefully. So let me see. So I equals 0, SI is 25 for a total cost of 1. Okay, so basically they're saying if I shift okay, I get it. So when you shift A to B, it costs you 1. But okay, for this forward cost, A to B costs you 100. So in this costs A to Z, A to B costs you 1. And then B, A to Z costs you 1. B to A costs you 100. B to A costs you 100. Okay, so this is backward cost, and this is the cost of shifting A to Z. This is the cost of Z. This is the cost of shifting B to A. So this is the cost of going backwards for B. This is going backwards for C. I see. That's why you cannot go from B to A. If you go from B to A, it's going to cost you 100. So you go from you have to go from A to Z to Y, blah blah blah, all the way backwards. Okay. B. Okay, you have to go from B to C, D, E, F, G all the way here, and then go backwards. Okay, so I think so. So I think the first step is to find a way to calculate, very quickly calculate what is. Yeah, you need a way to very quickly calculate how much it costs to shift one character to a different character. So if you just use this data structure alone, you want to calculate from, let's say, A forward to Z, you're gonna add this all up. A forward to Y, you're gonna add this all up. So you do a lot of you do like 26 times slower. So I wonder if already 150 plus except on 2. Yeah, people are very fast. Okay, so there's probably some. Here's, yeah. Yeah, I know, it's crazy. I'm just understanding the question. I'm still trying to understand what the question is talking about, and people are already accepted. Yeah. Well, what can I say? Some people are just they're super fast. I have no idea why. Okay, I must turn off this. Let me just make sure my assumptions are right. So the prev costs, the next cost and previous costs are length 26. So okay. Yeah. So there's probably some trick, if you want to think about it, is there's some trick to make it easy to calculate sums. There's some trick to make it easy to calculate sums across the range of array. You need some way of doing that. Oh, my mic is falling. There's nothing I can do about it. All right, cool. Now it works. All right. Hmm. Yeah. This question is not hard. I don't think so. I mean, this contest is not hard, at least so far. But we'll see. So you need some kind of data structure to quickly calculate. You need to sum up a whole range of the previous and next costs, right? So you need some kind of data structure that allows you to quickly calculate that. So that should be a pretty standard data structure. So think about it. So backward costs. Alright, let's see if this works. And just make sure I'm not giving away answers on screen. This case. Unsupported operand. What the heck is that? Welcome, welcome. If you have just joined us, what was I going to say? Yeah, if you just join us and you don't see anything happening on the screen, don't worry about it. Stuff is happening, I promise you. Okay. If you have questions, ask on the stream. Yeah. Okay, something is... $25 times the previous character for a total cost of 1. So A to B... Okay, A to B, if you shift forward... Next. Huh. Nope, this is not correct. So what about previous? It's absolute. Next index absolute aim. No, it's not. So I don't think that's the way to do it. You can't use absolute because which direction you go matters. Which direction you go matters. So basically, if you shift forward, A to B costs this, B to C costs this, C to D costs this, and so on and so forth. So which direction you go absolutely matters. Direction you go at matters. Yeah. So you can't take absolute. If you take absolute, then you would forget which direction you're going. And also, absolute A minus, you get a negative number. Oh, and yeah. Yeah. And you take S minus T, that's also not the shortest distance. Because if S is A and T is Z, then S minus T is going to be minus 26. And you take absolute of that, that's going to be 26. You have to take T minus S and then mod. Yeah. But again, notice that the cost going forward and backwards is different. So you actually have to pay attention to that. Yeah. Okay, I'm not gonna screw this up. I'm not gonna screw this up. Okay, beautiful. I think I got it. Okay, remember remove all the print lines, so you don't trip over the. I have not got it. Wait, previous course? This is correct. Oh, wait a second. What did I do wrong? Is it 26 minus next? No. So you need a data structure that's efficient in calculating. I'll talk about it afterwards. So basically, you need some kind of data structure that's very efficient in calculating if I move from A to B using previous or using next cost. What is the difference? I'll go over it later once we're done with the contest. I have a lot of bugs in my code I'm trying to debug right now. So oh crap. Okay. Yeah. Plus minus previous cost A. Okay, this is not correct. I didn't realize you can only use each query only once instead. Yeah. Okay. Something is not right here. Something is not right here. I don't know what it is. Not getting something right. A0, B is 1. Plus previous cost B. Minus previous cost A. Why is this not right? Well, math is right. 101. This 100 minus 101 is minus 1 plus 1 is 1. That's 0. Zero plus previous cost B. Cost B is minus previous cost A. Ah, crap. Okay, this one is wrong. Next cost A plus next cost B. Forward is 100. You see, plus previous cost B. So this is the last number minus cost B. This is 0 plus previous cost A is 1. Backward from A to B. Okay, A is 0, B is 1. Okay, A is 1, B is 0, and I want to go backward from so this is correct, and then plus. No, there's no plus previous cost B here. There's minus previous cost A. Okay, let me just check this. From this one back to this. C back to A will be previous cost C minus. Oh, okay. So I think this is correct. Alright, so zero array transformation. You're given an integer array nums of length n and a 2D array queries where queries I equals to L and R. Each query represents the following action nums. Nums of length n and 2D array queries. Decrement the value at each index by at most 1, so you can decrement it by 0 or 1. The amount by which is chosen independently. Okay, so each index from L to R, you decrement by 0 or 1. A zero array is an array with all its elements equals to 0. Oh, isn't this was a daily problem recently? Or this was like a contest problem? This looks super familiar. Return the maximum number of elements that can remove from queries such that nums can still be converted to zero array using the remaining queries. If it's not possible to convert nums to a zero array, then return -1. Okay. Maximum number of elements that can be removed from queries. Oh, this was last week's problem. Was it last week's problem? You can only use query one time. I don't think it's the same though. Wait, I don't think it's the same. I don't think it's the same. I think it's different. Because last week you have to go through the queries one by one, right? You have to go through queries 1, 2, 3, 4, 5, 6. This one you can remove any query from anywhere. Yeah, also I forgot the yeah, how was it done last week? You do some kind of interval. You're basically looking at some kind of interval for this one. Okay, hang on. Let me look at the last question first. I don't like question 3, so I might skip it. So there's a game dungeon comprising of n by n rooms arranged in a grid. You're given a 2D array of fruits of size n by n, where fruits ij represent the number of fruits in the room ij. Okay, 3 children will play in the same dungeon with initial positions at the corner rooms. 3 children will play in the exit according to the following rules to reach each room. N minus 1. Okay, so the children are trying to go to the bottom right corner. The child starting from 0, 0 must move from their current room ij to one of the rooms ij plus 1. Okay, so so let's see. So you have a grid. So you from here you can go here, here, or here, and you're trying to reach here. If it's 0, if it's here, then you can go to I plus 1j minus 1, I plus 1j minus 1, I plus 1j, or I plus 1j plus 1. If the target room exists, I plus 1. Wait. I plus 1j plus 1. But this target room does not exist. Okay, so if you're from n minus 1, n minus 1, 0, if you're here, n minus 1, 0, must move starting from, oh, okay. I see. So 3 children, 1A starts here, B, and then C starts here. So this guy, must move from their current room ij to one of the rooms I minus 1j plus 1, I minus 1j plus 1. ij plus 1. Okay, so this guy moves in like the southeast direction, B moves south, and C moves east. So when a child enters a room, they must collect all the fruit there. If 2 or more children enter the same room, only one child collect the fruits, and the room will be emptied after they leave. Return the maximum number of fruits the children can collect from the dungeon. Oh, okay. This is like a variation of the standard problem. the standard problem is only one child. So yeah, only one child. So the standard problem is only one child, like B, and then you go down, you keep going down and collect all the fruits. This is 3 children, and if the children go into the same room, the child go into the same room, they only one child will collect the fruit, and then the fruit will be emptied after child leaves. Okay. So for instance, in this case, and then this is the path. And they collect 100 fruits. And this is supposed to be the optimal path. Yeah, there can be quite a bit of overlap. So the best way for them to get here is to collect all 3. But that may not be the best way to get it, because this guy can be all the way here to collect a fruit, and then it comes down. Yeah, I don't know. I got to think about it a little bit. Okay, so array transformation 3. Can we use binary search for the third? I'm not sure. Yeah, it's remaining queries, but don't know how to give it all the possible combinations of remaining queries. Yeah, so it's different. So that's the difference between 0 transformation 3 and 0 transformation 2. So 0 transformation 2, yeah, in 0 transformation 2, you either take the, yeah, I don't know. It's basically, so this is like the, what you call it, right? It's like dynamic programming, right? Like the 1-0 knapsack problem is like dynamic programming. You go through each queries 0 to queries n. You either use a query, you either take the query or don't take the query. So I think it's some kind of dynamic programming. But n is very large, so I don't know how easy it is to check if this can be zeroed. Either you take or you don't take. So you take, your nums will all get reduced. By 1. Okay, I'm gonna try this. Yeah, let me see. I think a breadth-first search would work, but a breadth-first search might take a really long time. Yeah. It's gonna take a really long time. Because nums is very big. Oh, you cannot manually decrement. I actually forgot how. Oh, let me see. How did zero array transform 2 go? How do you decrement nums? Let me look it up. I think it was like last week's contest. Oh, the start and end. Okay, I remember how they do it last time. Is 4th DP and backtracking? Yeah, I don't know. I think 4 is definitely DP. 4 is definitely DP. So it's definitely some kind of DP. It's like a 2-dimensional array. But I don't know what is. Yeah, I think the backtracking might be very expensive. Because the length is 1000. The backtracking might be kind of expensive. I'm not super sure. So each one, if you do like brute force, it is the branching factor is very high. I wonder if you can take one of them, grab all the fruits, and then choose the second one, grab all the fruits, like write the optimal solution, and then third one, grab all the fruits, like the optimal solution, and do it like, like 3 times, and you try and figure out which is the cheapest. Like get a greedy approach. So you pick A, B, and C in that order. Take A, solve the problem for A, for just A, and then using the rest, whatever the state of the room is, solve the problem for B, and then solve the problem for C, and then reset. Now solve B first, then A, then C, and then reset, and then C, A, B. So that's like 6 different combinations. I wonder if that will work. Yeah, I wonder if that will work. Okay, wait a second. Actually, for question 3, if there are, so you basically have to sort the queries. Yeah, you sort the queries. For question 3, you sort the queries. Let's say the queries are like, okay, and you need each one to have enough coverage for your numbers here. So if the number here is 3, for instance, you have to select how many queries there are. That covers 3. Okay, so you need to select queries with this that cover 3. So let's say there are 4 queries that cover this one. You select 3 of them because it's at most 1, right? So let's say there are 4 queries that start that cover index 0. You have to select at least 1 of them. You select 3 of them. Okay, and then for each of them, you have to now go to the next n. Yeah, I think that's super slow. If they all clash, then you can either try giving all the fruits to one of the max fruits or backtrack. You shouldn't need to try all of them since you need to maximize the total collected by all. Yeah, I also think about backtracking. I think maybe you should optimize, let's say optimize for A first, get the maximum fruit for A, and then now, given the rest of the state of the room, get the maximum fruit for B. The largest range covering non-zero elements after sorting, but we can use only once. Yeah, I don't know. Yeah, I don't know. This one I kind of stumped, to be honest. I'm gonna see if I can. I'm gonna try question 4. I'm gonna do optimize for A first, and then optimize for B, then optimize for C, and so on and so forth. And I'm gonna see whether the greedy approach works. I think the sort of like pseudo greedy. So B keeps moving down. 0 and minus 1. Wait a second. So another way to think about it is that if you think about the square, so B and C can cover here and here. And then B and C can cover here and here. A can cover anywhere. Yeah, I don't know. I don't think that's the right way to go. I'm gonna try mine, which is optimize for one of the paths first. Okay. Let's see what else people are saying. Can you help me with 3? I don't know 3. Greedy meaning you take the path the max fruit each time. Yeah. So my strategy is to not take the max fruit each time. So my strategy is to solve so if there's only one child, whether it's A, B, or C, the answer is quite simple. It's just a DP problem. So my guess, I don't know whether it works, is to first solve the problem optimally for A, and then solve the problem optimally for B, and then solve the problem optimally for C. So that's sort of my strategy. So it's greedy in that I solve the problem optimally for one child first, whichever child that might be. I don't know whether this is the right solution, but I'm gonna try it. Yeah. I don't know whether it's should be hard, not medium. Yeah, it should be. It should totally be hard. Yeah, I think they sort of changed. I feel like they kind of changed the grading on LeetCode a little bit. They made everything a little bit harder. I don't know why they did that, because I think people are just solving the problems too quickly. Yeah. They're solving the problems too quickly. Yeah. So they sort of want to, inflate the difficulty a little bit. Because normally 4 points, 5 points, they tend to be quite easy, right? But this is like the 5, 6 points are pretty hard. Best because and max DOB fruit. They also inflated LeetCode points required for store. I was saving up for premium. Yeah, what's the LeetCode points for store? You mean you can get premium for free? I had no idea. I gotta check that out. Yeah, I'm trying the 6K points. 6K points for 1 month premium. Really? You can get free if you have 6K points. I had no idea. How do you see how many points you have? I see rating. I don't see points. Interesting. Yeah, I only did 2. Unfortunately, I'm trying the 4th one right now. And the way I'm planning to do it is I'm gonna try and get the optimal solution for A first, and then optimal solution for B, and then optimal for C. And I'm gonna see if that works. Hmm. Okay. Yeah, I don't think I have time to try out the plan that I had. Important point. Forget in fourth is each child will make exactly n minus 1 moves. Makes sense hindsight. Yeah, it's not just n minus 1 move. The child cannot go backwards. No, the child does not make exactly n minus 1 move. So B and C do, but A can make many moves. So like A can be like 1, 2, 3, 4, 5, 6, 7, 8. A can be many moves. The number of moves for A is not determined because like it can move here, right? If it moves a diagonal, so it can move diagonal. It moves the diagonal, then you lose out 1 move. Yeah, so this first one is diagonal. I plus 1, j plus 1. Yeah, I don't think I'm gonna finish. Wait, does it say A has to make exactly one move? Ah, crap. I didn't see that. It'll make exactly n minus 1 moves. So A also has to make n minus 1 moves. Oh, I get it. So A doesn't always go to the end. A may stay just in his quadrant. A may not go to the end. Yeah, I don't know what's. Yeah, I'm stumped. This one. Yeah. So maybe some kind of DP. Some kind of DP, everybody makes a move. But the DP has a lot of branching factors. Because, oh, it's like a 2D DP then. It's a two-dimensional DP because, well, actually more than that. Because A can be any of these. A can be here, 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 here. B can be anywhere on the row. C can be anywhere here. And then each of the positions for A, B, and C, you know, has like a maximum. Yeah. So you have to calculate at the end of each state. So like the branching factor is very high. It's very high. It's like 9. There are 9 possible places A, B, and C can end up. And after 3 moves is 1, 2, 3, 4, 5. This would be, yeah. Or maybe none. Maybe it's not that high. Yeah, maybe it's not that high. Yeah, I don't know. Either way, I think that the contest is coming to an end. So before folks leave, I'm gonna do my usual plug, which is if you enjoy this channel, please like and subscribe. If you don't want to do that, the sort of easiest way is just click the like button on this stream that you're watching right now. That's gonna help me out a lot. If you can comment on the VOD when it comes out in like 30 minutes, it's gonna help me out a lot. Just write a comment if it yeah, just write a comment on the video if you can. It does help me out. You subscribe to the channel, then you can see when I'm gonna stream. The contest is ended. Done. Yeah. Well, I only managed to do 2 problems. This is a bit unfortunate. I hope you guys managed to do better than me. I do think there's some difficulty inflation because I feel like if you look at this 3, 5, 5, 6, these are not like this is harder than the normal 6. Normally 6 is not that hard. 5 is, yeah, this one is not 5, right? This one is 5, but this one is definitely not 5, right? This is kind of a little bit harder than it normally is. That's my gripe. Or maybe I'm just bad. Maybe I just need to get better. Who knows? I'm curious what people are talking about with the points. Like, how do you find out how many points you have? How do you find out how many points you have? It doesn't say here. It just says contest rating. Badges. it says these things. Huh. Yeah, I don't know. I don't know. How do you find out how many points you have? Third one, click profile and credits. Third one is harder. One easy was very, very easy. Yeah. 2 is like 5. 3 is like a 7. Yeah, 3 is so hard, man. That is what the heck? 3 is hard. 3 is at least a 6, if not a 7. Points is on your screen right now. Am I? Oh yeah, I see the points button. Oh my god, I'm blind. 3,000 points. What do you need for points? Oh, you need to participate. Yeah. Well, I'm not gonna participate. I mean, I participate in the coding challenge, but it's a participation score, so I don't think I'm gonna get that many. So 3,000 points. Oh, and if you rank within the top 200, you get 50 points. I think I've ranked within the top 200 once in my entire life. And I've participated in like a lot of contests. At least 30 contests. 30 contests. Yeah, I don't even remember if I've ranked within the top 200 ever. If I have, it's just one time. And I've done a lot of contests. So I don't think that's going to happen anytime soon. But we'll see. I'm failing at 730th test case in third. I have 2,000. Nice. The best rank I have ever gotten somehow. Yeah. Okay. Almost done with fourth. Oh, Satyam Raj. Very nice. Very nice. Yeah. Great job, guys. You know, let me know. Just comments in the video which... comments in the video how many you've done. I'm actually kind of curious to see how many of you guys done. I've been on a losing streak when I live stream. So what I do sometimes is I will do the contest off stream. Off stream, I can concentrate a little bit better. So I do tend to get slightly better results, but very slightly. Rohan Sharma, welcome back. Good to see a familiar face. Not able to do today because of wedding my friend. Well, tell your friend congratulations from the good people at Alex Does LeetCode. Not that he cares, but I think everybody in your channel congratulates your friend on his wedding. A shout out to your friend. Yeah. Okay. Let me see. Yeah, you're welcome. Thanks, Alex. You know, I don't know your friend. I assume it's an Indian wedding. I heard that Indian weddings are very elaborate. I heard Indian weddings, you know, I have a lot of Indian friends because I'm in CS. And my Indian friends tell me the weddings are like 2 or 3 weeks. I always wanted to be invited to one of those weddings. Maybe one day. Your best rank is 2200. That is very nice. My best rank is a smidge over 2000. So I only got 2000, around 2000, less than 2050. So you're doing really well. Yes. Only 2. What's your suggestion for beginner in coding? For beginner in coding, I think the contest is actually not that realistic. It depends on what you want to do. If you want to get better at programming, then I think you should just focus on the easy and medium. And then after that, you should go work on a project. Go do an actual software engineering project. Because building an actual application, any sort of application is so different from solving LeetCode problems. LeetCode problems are like doing trick shots, you know? Like if you want to become a good basketball player, you have to play a lot of games. And you have to learn all the different parts of the game. The strategy, the dribbling, the layups, whatever. But LeetCode is just one part of the game. It's like if you want to become a good basketball player and you learn how to shoot basketball in very clever ways, from far away, with blindfold, all kinds of weird trick shots, it will help you only a little bit because you're not leveling up the rest of your game. The rest of your game, like how to work in a team, how to manage very large projects, how do you design interfaces and architecture, how to reuse libraries that somebody else has written for you. So those are really important. So if you're a beginner in coding, my recommendation is do the easy problems. And you can do a little bit of the medium problems. But once you're really good at the easy problems, then you should start doing projects, actual real projects. There's this book I like a lot called Automate the Boring Stuff. Go check out this quote called Automate the Boring Stuff. This book has a lot of project ideas, so they'll lead you through projects like web scraping or do like simple, I think there are some apps in there also. So if you want to get better, become a better software engineer, this is the way to go. He did 2 questions. He's not a beginner. I don't know, dude. I think, in the grand scheme of things, we are all beginner, right? I wouldn't gatekeep anyone on that. I also did 2 questions, so maybe I'm also a beginner. I think most people on this channel also did 2 questions. Today was tough. So cut us some slack, Nash. Yeah. Indian weddings are fabulous. It's like a festival for us. Yeah. One of these days. I have so many friends who are Indian because I'm in CS. All my friends are Indian. So one of these days we can make it to India. I'll try to go to an Indian wedding. I heard so much about it. Alright. So let me get my water. I'll come back where we're gonna go through answers as best as I can. Give me one second. Nash, the thing is, I like my theory is I don't compare with other people, I just compare myself. At the end of the day, it's not a contest against other people. I have to think about what I actually want to do with it, whether in LeetCode or in life. The goal is to make things better for me. Whether people do well or do poorly, it doesn't affect me. I just need to compare with myself. And as long as I'm doing a little bit better each day, I'll be happy. If somebody's doing really well, I'm gonna be happy for them. And I feel like if you compare to other people, you'll always be unhappy because there's always going to be someone who is smarter than you, richer than you, better than you in every way. So I would just focus on myself. Okay, alright. Cool. So let me get the YouTube script. We are discussing solutions for LeetCode Biweekly Contest 144. Jump to specific questions using timestamps in the video description. Check out the rest of my channel. If you enjoy LeetCode contents, like and subscribe. Stay up to date on new videos. If you enjoy my video, definitely leave a comment in the VOD. Tell me how you did on the contest, whether it was easy or difficult for you. Leave a like, and all these things will help me out and help us get more people into this channel, and we can all hang out here together. No, I'm not going to do third. Well, I'm going to start with 1. And as you can see, I didn't manage to do the third question either. I can tell how I think about it. We can talk a little bit about the last week's Zero Array Transformation 2, which I think is similar. But I don't know where to do that. I tried doing 4th. I don't know if I got the right path. Okay, but without further ado, Question 1. So, question 1, stone removal game. Let me read the question. Alice and Bob are playing a game where they take turns removing stones from the pile, with Alice going first. Alice starts by removing 10 stones on her first turn. And then Bob will remove 9 stones. So, Alice removed 10 stones. And then Bob removed 9 stone, then Alice removed 8 stone, then Bob removed 7 stone, so on until all the stones are done. So the maximum number of stones is 55 because 1 plus 2 plus 3 all the way to 10 is 55. And n is smaller or equal to 50, so we're good. We're never going to run out of stones. we're never gonna run out of moves. The stones will run out before the moves run out. So the way to do this is pretty straightforward. You simulate exactly this process. So you start while true, keep going until n is done. The number of stones to remove, it starts at 10. N starts at n. So first you simulate Alice's turn. If there aren't enough stones left for Alice to take, so if the amount of stones that Alice is supposed to take is larger than n, then return false. Alice loses if she cannot move on her turn. If she doesn't lose, then you remove that number of stones from n, and stones minus equals 1. So stones are at 10, Alice's turn, at the end of Alice's turn, stones is 9, and n is 10 smaller than it used to be. Now it's Bob's turn. Same rule, if stones larger than n, if the number of stones that Bob needs to remove is larger than the current pile, which is n, then return true. True means Alice wins and Bob loses. And now you decrement the pile and you decrement the number of stones. And you keep going until the end. This will never actually be reached. You'll never reach return false. Because n is at most 50. So you're guaranteed that this game will end at some point. And I think that's all there is to it. You run it, it will work. Okay, cool. I don't think there are any questions about this. Okay, question 2. Shift distance between two strings. You are given two strings s and t of the same length, and two integer arrays, next cost and previous cost. In one operation, you can pick any index I of s and perform either one of actions. You can shift si to the next character. If si equals z, it rotates back to a. So a to b, b to c, c to d, right? Forward. This shift forward. This operation costs next cost j, where j is the index of si in the alphabet. So how much it costs to shift forward depends on what the letter is. It depends on what the letter is. How much, and the other thing you can do is shift backwards. So same thing. C to B, B to A. A, if you're at A, you shift backwards. It goes all the way back to Z or Z. And the cost of this operation is previous cost, where J is index of SI in the alphabet. So what that means is, let me get this thing out. So if A, B, and the shift distance is the minimum cost of operations required to transform S to T and return the shift distance from S to T. So you want to transform, let's say, S, A, B, to T, B, A, okay? The shift distance, the cost is the cost of all the, each letter. It's the cost of each letter. So basically, for each letter, let's say A to B, you can either forward, which means A, B, or backwards, which is A, Z, Y, D, C, B. You can go backwards. You can either go forward or you go backwards. Now, you might think that forward is cheaper because only one step, and backwards is more expensive because many steps. That's not always true, because the cost depends on the cost array. In this case, forward, if you want to go from A to B, forward is A is 100. It costs 100 to go from A to B because this thing here is 100. If you go backwards, A to Z to Y to X to W, blah, 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 all the way to D to C to B will actually cost less because A to Z costs 1. This is backwards, right? This is backwards. Z to Y costs 0. Y to X costs 0. X to W costs 0. All the way is all 0 until C to B costs 0. So the cost of this the cost of this is going to be less than the cost of shifting forward. It's going to cost less than cost of shifting forward. Okay. Now, so how do you calculate this? Basically, the basic structure is for each character in S, calculate the forward cost, and then calculate the backward cost, and then you take the minimum of the forward and the backward, and then you sum them up. And that should be done. So you take the first character, you calculate the forward cost, you calculate the backward cost, you take a cheaper one, and then it's done. Okay? Now the naive way to do this, is for every character, you're going to sum up, right? So if I want to know what's the cost from A backwards to B, I'm going to take this, I'm going to add this. You can sum them all up. You sum them all up, that would, that would be your backward cost. That's actually not the most efficient way of doing things. That actually is going to be, do 26 operations every time you have a character. I don't know whether that will work, whether that's fast enough. It might be, I don't know. But there is a better way. So the way I did it is basically using a prefix sum. So if you want to sum up parts of the array, right? You want to sum up a sub-array in an array. Always think prefix sum is one of the most common ideas for doing this. A prefix sum basically says a prefix sum basically is the sum of that element plus everything before it. So the prefix sum of, let's say, F is going to be 100, and then 0 is going to be 100. It's going to be 100 all the way. The prefix sum of B, the backward cost, is going to be 1. And then 1 plus 100 is 101. And then 101 plus 0 is going to be 101. All the way. Okay, the prefix sum. So if you calculate the prefix sum, it becomes easy to find what's the forward cost and backward cost. So you can just take whatever index this is. You're supposed to go from index 0 to like 8, right? You just take the prefix sum here minus the prefix sum here. And if you want to go from, backwards from, let's say here is A and here is B, right? You want to go this way. Then all you do is take the prefix sum of this plus the last number minus the prefix sum of this. So that's how you calculate. Yeah. So if you do that, basically you have a structure that allows you to quickly calculate how much the forward and backward costs are. Yeah, I'm curious if any of you tried the brute force method and it worked. I don't know if the brute force method works. Yeah. Do you do the brute force method? I wonder if the brute force method works, because it's a fixed length, right? It's only 26. So the cost will be 26 times higher than using a prefix sum. And since, like, in terms of your big O notation, it's the same. It's multiplied by constant. So I wonder if it works. So this is basically a prefix sum. I calculate prefix sum. Total equals 0. Now the thing to note is that I'm just going to remove all the print statements. The main thing to note is that the costs of rotating each character is independent. So for each character you calculate A and B. This is turn the character to an index. I calculate the forward costs. The forward cost, if B is larger than A, then I just take the prefix sum of B minus the prefix sum of A. If A is larger than B, then you have to go A has to go all the way to the end, and then go all the way to n minus 1, and then from 0 goes back to B. So it's a little bit more arithmetic, but it's the same idea. So backward cost is the same. You just again use the prefix sum. You see that there's no for loop here. There's only one for loop outside. There's no inner for loop here. So it's a bit faster. So total plus minus mean forward and backwards and return total. And that's basically it. Let me check if there's any question. You did brute force? Yeah, it's 0.26. Yeah. Time complexity will be 26 times faster. So 26 is a constant. I don't know. I just jumped to prefix sum right away. Yeah. If you use brute force, it looks like brute force works. Yeah. Maybe next time I'll just try the brute force first. Well, I was actually a little bit scared because I was worried if I tried the brute force and it didn't work out, I'll lose 5 minutes. Yeah. That's pretty much the only reason. Maybe I should have been a little bit less ambitious. Okay. So, question 3, zero array transformation 3. So this question is actually the same as last week's question. Last week was zero transformation 2. So last week's contest is zero transformation 2. But let me explain both of these. Zero array transformation 3. You're given an integer array nums of length n and a 2D array queries, where queries is I to R. Each query represents the following action on nums. Decrement the value at index at each index in range L left to right in nums by at most 1. You can choose whether to decrement or not. You probably want to always decrement unless the element is 0. And a zero array is an array with all its elements equal to 0. Return the maximum number of elements that can be removed from queries such that nums can still be converted to zero array using the remaining queries. This, I always hate this kind of phrasing. Basically, it's saying what is the minimum number of queries inside queries that you need to keep in order to turn nums into a zero array. So, like, it's weird that it says maximum number that you can remove. Basically, it's the minimum number to keep, and then you subtract it by the length. Either way. Okay, so here's an example. Let's say your query is 2, 0, and 2. Your nums is 2, 0, and 2, and your query is 0, 2, 0, 2, and 1, 1. So what you can do is you can do query 0, Q0, so 0, 2, 0, 1, 2, right? It starts from index 0, ends in index 2, so it encompasses the entire array. If you run query 1, it will decrease each of these by 1. It's 0, so it stays at 0, it doesn't go down. So this is query 0. Using queries 1, 0 is again 0 to 2. You'll decrease each of these by 1. So 1 becomes 0, 0 is 0, and this is 0 again. Okay, so so the idea here is out of these queries, what's the minimum number of queries that you can take? Or the maximum number to remove, which is the same question essentially, where you can bring nums all the way down to 0. What's the minimum number? So last week there's a very similar problem. Last week there's a similar problem, which almost exactly the same, except that instead of choosing any arbitrary set of queries, you are basically choosing the first k queries, such that after processing the first k queries in sequence, nums becomes a zero array. So that's a slightly different. Yeah. So I think this question is basically, it's like dynamic programming. You take or you don't take. You look at this, you either take it or you don't take it. That's as far as I got. I'm not sure what is the right solution. The other thing to note that is the same for versus last week is that you probably don't want to go through the entire array and decrement them manually. You don't want to do that. Instead, what you want to do is you want to you want to take the L and R. Let's say Q0L is 2 and Q1R is 2. What you want to do is take the L and R, and you want to essentially say that at 0, I have a -1, and at index not 2 but index 3 I have or maybe you can say +3 +1. I have a -1 at index 3. So the reason why is because if I manually decrement all of this, it's going to take a long time. Whereas if you sort of like do this +1 and -1 thing, it becomes easier to aggregate all these queries together and test them out. Yeah. So I am not super sure. I'm not super sure what the solution is. I think about it a little bit more. But I do think that it's going to be similar last time. It's better to do optimal first if you think of it. That's in reference to the previous question. Okay. So if somebody knows, somebody managed to successfully do 3, let me know in the comments, or write the URL to your solution. I would love to look it up. Just let me know. I'm very curious about 3 because I managed to do 0 array transformation 2 the last time. So I think it should be similar, but it's different enough that I can't just copy and answer over. Okay, let's move on to question 4. Okay, so question 4. There's a game dungeon comprised of n times n rooms arranged in a grid. You're given a 2D array fruits of size n times n, where fruits ij represent the number of fruits in the room ij. 3 children play in the game dungeon with initial positions at corner room 0, 1, at basically the 3 corners. A, let's call him A. Child A starts top left. Child B, oops. So child A starts the top left, child B starts the top right, and then child C starts bottom left. And the idea is as follows. Let me erase this first real quick. I want to go through I want to read the text of the problem because the text is very dense. Just reading this is very confusing. I hate reading these things. But I can tell you from my experience as a software engineer, you will get text specs that look like this kind of crappy, confusing language, because the people who write text specs are not very good at writing text specs. They are neither engineers nor are they writers. They are just random people. So it is your job to decipher what is essentially a very confusing text spec. So it does make sense to train your English skills if you want to become a better programmer. Okay, so basically there are 3 children playing in the dungeon. Okay, the children will make exactly n-1 move. All 3 children will have to make exactly n-1 move. The person who starts top left, let's call this guy A. Can move I plus 1, j plus 1. So this is diagonal down. I plus 1j is this. And then ij plus 1 is this one. So we can move one of these 3 options. Child B, who starts from 0, n plus 1. Can move I plus 1, j minus 1, this. I plus 1j or I plus 1j plus 1 here if it's valid. And likewise, C can move to the right. So I minus 1, j plus 1, I, j plus 1, or I plus 1, j plus 1. So each of them can move 3 different directions. And the idea is their job is to collect fruits. Their job is to collect fruits. And every room will have an aroma of fruits. And their job is to collect as many fruits as possible from the dungeon. Now, if there's one child, the problem is very simple. If there's one child, it's just dynamic programming. It's a very classic problem. We've all solved this problem a bunch of times. But for 3 children, the branching factor is much higher. And for 3 children, the rule is if you have 2 children enter the same room, and only one of them will collect the fruit. So you cannot actually solve for A, B, and C separately, because A's path and B's path and C's path will affect each other. So you have to you can't you can't find the optimal strategy for each of them and sum them up. So here's an example of the path in action. So in this example, A goes from here to here, from here to here, and then here to here. B goes from here to here, here to here, and then here to here. And then C goes from here to here. So they all have distinct paths. And the sum, their score will be the number of fruits in all of these added up. I don't know if they are required to have distinct paths in order to maximize their score. I don't think so. I think they can overlap if that allows them to reach certain squares that will yield the largest fruits. Yeah. I also know that you can solve each of these guys optimally stand alone and then sum them up. So my sort of the strategy I tried a little bit is I tried to solve. Let me refresh this. I tried to solve each person individually. So I have one function that uses dynamic programming to solve for child B. I have one function to solve for child A and one function to solve for child C. But each time I pass in this thing called used. So if I solve for A first, I'll solve as if A is the only child in the room. And I'll figure out his path. And I'm going to pass this used for his path to the next person. And next person will solve optimally based on the current state of the room. And use basically says that room was used by someone else already. You cannot go back there. And try to solve it from there. So my plan was to get optimal solution for A and then optimal solution for B using the state of the room after A, and then optimal for solution for C based on the state of the room after A and B, and then try A, C, B, B, C, A, B, A, C, ... So there are 6 possible combinations. That's my plan. I don't know if that's the best plan. I really don't know. I don't know whether it's the optimal plan. I didn't have time to try it out. The other plan that we can do is basically to do dynamic programming. So you have the state of the room. You have the state of the room. You have A location, B location, C location, and you have all the fruits that are being used. And you have like a used set, which is all the rooms that have been conquered by at least one person. So you use this and then you figure out and then the score and steps. So I don't know which is this can work, but the branching factor is very high. The branching factor is super high. At each turn, A, B, and C have 3 possible places to go. So it's a score of 9. I don't know if I don't know if this is the best way to do it or not. I'm not sure. Yeah, because of the high branching factor, you actually have to explore a lot of different paths. And because of this used, it's very unlikely that memoization will help you. So I'm not super sure. Maybe somebody would have a better way. I might look this up after the contest ends to see how the people who got it done actually got it done. Either way, let me see if there's... B and C have very limited paths. Not really. Their paths is half the room, half of the castle. So like B can go all the way here, and then C can also go all the way here, right? C can go here, 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 here. Yeah. So it's each of them have half the room. Their paths are not that limited. Yeah, and because n is 1000, n is not small. If n is like 50, then maybe it'll work. I'm not sure. I've got to try it out. The key is only follow the diagonal. A doesn't have to follow the diagonal path. Are you sure? Wait. A doesn't have to follow the diagonal path. I don't think that's correct. Because A doesn't have to end up at the bottom right corner. Right? Number of fruits, 3 children with initial position 0, 0, 0, 1. Yeah. So if A starts here, A can be like 1, 2, 3, 4. So 5 by 5, it has to move 4 steps. A can move 1, 2, 3, 4. And that is path. He doesn't have to end up at the bottom right corner. Because A takes n minus 1 steps. He doesn't have to end up at the bottom right corner. So I don't think A has to take the diagonal path. Yeah, I have to think about it a little bit more. I'll see what other people... All the children have to end up at the bottom right corner. Wait, where does it say that? Oh, it has to reach the room n minus 1, n minus 1. So it does have to reach the bottom right corner. So A is going to take the path. I see. So A is constrained to take the diagonal path. You're right. Oh, okay. So if A is constrained to take diagonal path, then the problem becomes much easier. Much easier. Like 10 times easier. Because now you only have to care about B and C, and the branching factor is not that high. And their path is quite restricted, to be honest, because it's like one triangle. Yeah, interesting. Yeah, this is interesting. So I guess I misread the problem. Yeah. So do you manage to do question 4? Do you manage to complete question 4? This is my surprise face. Do you manage to complete question 4? If you did, well, no. Yeah. Yeah. I got to think about it. I'll try again tomorrow. Yeah. I might try again tomorrow, so when I have more time. Yeah. This is very interesting. Yeah, this is pretty interesting. Okay. All right, that brings us to the end of the stream. Thanks a lot, folks, for coming, and thanks for the people who interact with chat. It's always fun to talk to all of you guys. Hope that you had a good contest, you did well. If you didn't do well, it's fine, because as long as you learn something, I think that we all win. Thanks for streaming. You're welcome. I want to say it's my job, but maybe it's I actually have a real job. Either way, thanks for coming here. Like and subscribe if you enjoy my content. Just toss me a like and add a comment on the video when it comes out in like 10 minutes. That's going to help me out a lot. Other than that, I hope to see all of you next week. Next week we're doing the weekly contests. It's going to be on Sunday morning if you're in India time, or if you're in USA time, it's Saturday night. For those of you celebrating Thanksgiving, happy holidays. If not, take care. Goodbye.